Welcome back, dear students. So let's continue with the exercise 20b, and today I'll be doing the last few problems, and with this we close this particular exercise. So I'm taking the first question to be question number 16. Okay, so we have the length of a hall is 18 meter and its width is 13.5 meter. Okay, so there's a hall, and if this is the floor of the hall, its length is given to be 18 meter. Okay, so its length is given to be 18 meter. So let me write the measurements. So 18 meter and its width, so this is your width, which is given to be 13.5 meter, right? So you need to find the least number of square tiles, each of side 25 centimeter, required to cover the floor of the hall, number 1, without leaving any margin. Okay, so basically what you are doing is, on the floor you are going to put tiles. Okay, and the dimension of tiles is also given. So basically you are using a square tiles. Okay, and the measurement of each side is given to be 25 centimeter. Okay, right. Now for finding how many tiles that can be accommodated on the floor, there's a formula that you need to remember. Okay, so I'll write down the formula here. So number of tiles will be equals to area of the floor divided by area of the tiles. Okay, so we will find area of the floor and area of the tiles. So there are two cases given to us. So number 1, without leaving any margin. So you are not leaving any margin like this. Okay, so you are starting from here only. Okay, so you are trying to cover from the border itself, right? Okay, so let's see the solution of this particular one. Okay, so I hope the formula is clear to you. So let's first find what is the area of the tiles. Okay, so it is given that okay, so each side of the tiles, okay, so each side of the tiles is given to you 25 centimeter, right? So let's convert this into meter. It becomes 0.25 meter. Now why am I converting into meter? Because all the measurements are in meter. Okay, so I told you in the denominator you have area of the tile, so therefore we will find its area. So area of the tiles. Okay, so area of the square tiles, let's say area of the square tiles. So it is equals to, you know, formula is a square, side is square, right? The side is 0.25, right? So its square will be equals to 0.0625 meter square. Okay, so we have area will be equals to 0.0625 meter square. So this is your area of each tile. So let's start the main question. So it's number 1. So if you don't leave any margin, then the area of the floor. Okay, so area with when there is no margin on the floor, then area of the floor becomes, it's easy, so it will be length into breadth. Okay, so length into breadth is 18 into 13.5 meters square. Okay, so if you want to find the product, that is also fine, otherwise you can leave it here itself, right? Okay, so therefore number of tiles. Okay, so number of tiles will be equals to, so I told you formula is area of the floor by area of the tiles. Okay, now what is the area of the floor? Area of the floor is this much, right? So entire thing, so 18 into 13.5 divided by area of the tiles is given to be 0.0625. okay. Now the calculation part I am leaving it to you. You have to do the calculation by yourself. So if you do the calculation, it turns out to be 3888. okay. So these many numbers of square tiles are required to cover the floor without leaving any margin. okay. Also the next part says, in each case find the cost of the tiles required at the rate of rupees 6 per tile. Now if the cost of one tile is rupees 6, then you have to find the cost of the entire tiles. okay. So therefore cost of the tiles at the rate of rupees 6 per tile, at the rate of rupees 6 per tile will be equals to rupees 6 into how many tiles do we have? We have 3888, right? So just multiply, you get your answer to be 23,328. okay. So this will be your answer. So these two are your answer for the case number 1. okay. Now for case number 2, I'll just give you one hint. So in case 2, what you are doing is you are leaving a margin of 1.5 meter all around. okay. So basically what you are trying to do is, okay, so let me show you using this. okay. So we have a case like this. okay. So we have a case like this. See here carefully. So we are leaving this margin. okay. So we are leaving a margin here, and this width is given to be this width. okay. So this width is given to be exactly 1.5 meter. okay. So in number 2, okay, in number 2 what you will do is, let me erase this part. okay. So I'll just write down here for your reference. So in number 2, length, okay, or dimension, length of the floor, let's say length of the floor will be how much? It will be, see, from here to here is 18, right? So from 18 I'll remove 1.5, and this is also 1.5, so altogether it is 3. So it's gonna be 15 meter. okay. So that means this is going to be 15 meter. okay. And similarly your breadth, okay, so similarly your breadth is going to be, this is 13.5, right? So this is 13.5, and from here I need to remove this and I need to remove this. Altogether this is also 3, so this becomes 10.5 meter. okay. So this becomes your 10.5 meter. okay. So everything becomes same, only thing will be this becomes 15, and here it should come 10.5. okay. So number 2 start like this, and you can do the same. In place of 18 you write 15, in place of 13.5 you write 10, you get your answer. okay. So I'll leave the part number 2 for you to do by yourself. You may pause the video and note down your solution. So next we have a rectangular field. So diagram is not given actually on the book. So we have a rectangular field 30 meter in length and 22 meter in width. Two mutually perpendicular roads, each 2.5 meter wide, are drawn inside the field so that one road is parallel to the length of the other field and the other road is parallel to its width. Calculate the area of the crossroad. So basically there is a park, okay, or there is a field, rectangular field, and there are two perpendicular roads. okay. So this one road, this another road, and the width of the road is given to be 2.5. that is, this is given to be 2.5, this is given to be 2.5. okay, right. So you need to find the area of the crossroad. okay. See, one road is parallel to length, another road is parallel to width. okay. So you need to find the area of the crossroad. okay. So basically what you need to do is, see here carefully, what kind of shape is this? Let's try to understand. Okay, so if you observe only this one, this is also a rectangle, right? So can you find the area of this? Yes. Okay, so let's find the area of this crossroad. Okay, so area of the crossroad. So area of the crossroads will be equal to, so we have area of one road. Okay, so area of one road. Now we will first find area of this is my first road. Okay, now you have to add this area also, remember. Okay, so let me write area of other road. Okay, but see here, when you include this part is already included, isn't it? Right? But when you're putting second road, that time also you are adding this. Okay, but this became extra, right? Because this was already included in the first road, right? So we have to again remove only this part because of this second road. Okay, so I'll subtract area of the common square. So see, this is common, right? This area is common, and this is a square shape, right? So we'll write area of common square. So this will be equals to area of first road. So this is a rectangular size shape, right? Whose length is how much? 30 meter. So it will be length into breadth. Breadth is given to be 2.5. Okay, plus area of other road. Now this becomes length in this case. So length is 22. So L into B. B is again 2.5. Now area of the common square. So this is a square shape of each side to be 2.5. So that's why its area becomes 2.5 square. Okay. Now you just need to calculate this. So let's quickly calculate. So we have 30 into 2.5 will be 75. So this is your 75 plus this becomes 22 into 2.5 is 55. So this becomes your 55 minus, so 2.5 into 2.5 is 6.25. Okay, so we have 6.25. So let's evaluate this quickly. So we have 75 plus 55 minus 6.25 will be 123.75. Okay, and your unit will be in meter square. So this will be your answer for this particular question. Okay, pause the video and note down your solution. Okay, so this will be the last question from this particular exercise, which says the length and breadth of a conference hall are in the ratio 7:4 and its perimeter is 110 meter. Find the area of the hall, number of tiles, each a rectangle of size 25 centimeter into 20 centimeter required for flooring the hall. Number 3, the cost of tiles at the rate of 1400 per 100 tiles. Okay, so a similar kind of problem which we have already seen. So first and foremost, length and breadth are given in the ratio 7:4. So we will assume that let length is equals to 7x. Okay, and it's given in meter, right? So meter, and let me take breadth to be equals to 4x meter. Okay, now what is given? Perimeter is given. So perimeter is given to be 110 meter, right? So you know perimeter formula is 2 into L plus B for a rectangle. So it becomes this much. So let's put the value. So 2 into L. L is 7x plus we have B. B is 4x, right? So this is 110. So we have, okay, so 2 into, this is 7 plus 4 is 11x is 110. So we have x from here is 11, 110 divided by 2, and 11 goes to the denominator. So do the cancellation. You get this to be equals to, so 5, right? So 11 this becomes 10, so 2 1s are 2, 2 5s are 10, so this becomes 5. Okay, so therefore your length, okay, so length will be 7x, that is 7 into 5, which is 35 meter, and your breadth becomes 4x, that is 4 into 5, which is 4 into 5 is 20 meter. Okay, so we got length and breadth. Now question is asking you to, number 1, find the area, right? So area of the floor becomes, so let's see what will be the area of the hall, right? So number 1, number 1 we have area of the floor, okay, or hall you can write. So it is length into breadth, that is 35 into 20, which is 35 into 20 is 700 meters square. So this is your first answer. Number 2, you have to find number of tiles, but for that what you need to do is you have to find area of the tiles, right? So area of the tiles, okay, so it is given to be 25 centimeter into 20 centimeter. This is the dimension, right? But we will convert this into meter, right? So we have 0.25, 25 centimeters, 0.25 meter, and this becomes 0.2, so this becomes meter square. Okay, so multiply these two, you get 0.25 into 0.2 will be 0.05. Okay, so it will be 0.05 meter square. So therefore number of tiles, so again the same formula, you will write the formula, area of the floor divided by area of the tile. So area of the floor is 700, and it is given that area of the tile is 0.05. So we have, this is equals to, so 700 divided by, this will be 14,000, I'm sorry, so it will be 14,000. So the number of tiles required will be 14,000. Number 3, question is asking you to see cost of 100 tiles. Okay, so cost of 100 tiles is equals to rupees 1400. Okay, so that means cost of one tile will be rupees 1400 divided by 100, which is 14, right? And question is asking you to find cost of how many tiles? Cost of these many tiles, right? So therefore cost of 14,000 tiles will be rupees 14 into 14,000. Okay, so it becomes rupees, so this is 196 and we have 000. So we have 1,96,000 will be the cost of these many tiles. Okay, so these are your answers, and with this we close this particular exercise on rectangles and squares. Okay, thank you very much.